Okay, so rational root. Realize that the video that I originally recorded didn't have sound for some reason, so I'm going to do a quick summary of how rational root theorem works. So let's say that you have a equation, and in the past we've always given you what to put out here. Now you have to figure out what to put out there. Let's say that I had this problem, plus 5x plus 10. How do you know what you could possibly put out here? You know, what we would do is typically like say, oh, by the way, x plus 2 works. But what if you don't know what to put out there? Here's how you do it. You do the factors of the constant over the factors of the coefficient. And what is the constant? Do you guys know that that one's called the constant? It doesn't have a variable, okay? And so what are the factors of that constant? What are some things that go in it? 10 and 1. I'll start in order from small to big. How about that? 1 goes in it. 10 does go in it, but that's going to be at the end. What else? 2 goes in it, and 5 goes in it. There we go. Those are the factors of the constant. So hint, one of those is probably the thing we would put out here. But if I said 2 was it, do you get that means it would be x minus 2? Do you get what I'm saying? If I said 2 was the thing that goes in it, that's called a factor, or that's called a root, and this is called a factor. So let's say I had this, x minus 4. That's a factor. What's the root that goes with it? Do you get how these are opposites in sign? Okay. So if I realize that the root comes out to 5, then the factor would have to be what? All right, just making sure you get that they're different. They're opposite numbers, and one of them has an x. This kind's called a factor. This kind's called a root, and that's how they're related. All right, so now this is called the rational root theorem. So we don't find factors with it. We don't find things like x minus 2. We find just a number like 2. And 2 is the number that works in this one. Now, how do I know that? Watch. I take those factors of the constant, 1 and 2 and 5 and 10, and then I find the factors of the coefficient. The coefficient is this number in the front. Okay, that coefficient that's in the front, what are its factors? 1, just 1. So then I take these and divide by those. But it's really simple if it's just 1, because dividing by 1 doesn't really do anything. So here's all the possibilities, and that's the first few questions in your Schoology quiz are just, what are the possibilities? So I take 1 divided by 1, and I get 1. 2 divided by 1 is 2. 5 divided by 1 is 5. And 10 divided by 1 is 10. And so these are my answers, and you just got to remember it could be positive or negative of all of them. Those are the possible roots. Now, how do I know which one actually works? The way you can tell one actually works is if I take it, stick it in, and either do long division or synthetic and see if it works. So if I think 2 is going to be it, then x minus 2 is going to be the thing I would check. Now, you got to be good at synthetic and long division because they're going to happen a lot. All right, I'm going to move these. This is my prize answers, and I'm going to set them over here. And I'm going to leave room for doing a synthetic. I want you guys to try, if I put a 2 here, notice I didn't put a negative 2, I put a 2. If I put a 2 here, then I would go 1, 2, 5, 10, draw the line, and hint, it's not going to work. Then how do I know? Well, I'm going to check. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. 8 plus 5 is 13. 13 times 2 is 26, and that ends with a 36. It didn't work. How do I know it didn't work? Didn't end on 0. Okay, so there was not a 0 remainder, there was a 36 remainder. So 2 is not it. All right, well, I tried. And I know now the regular 2 doesn't work. Let's check negative 2. Let's see if that one works. 1, 2, 5, 10. You do synthetic. 1 times negative 2 is negative 2. Add them, multiply them, add them, multiply them. Sweet, it worked. I have a 0 here at the end. I want you two to together figure out what the factors are then. What does this mean for a factor? And what does this mean for a factor? That's just synthetic. We did it the other day. This one was x plus 2, and then what goes here? Pause for a second while you guys try that. So, in here, you should say this is x to the 0s, x to the 1s, and x to the 2s. That's how you do this. And this is 1x squared, which I just would call x squared. And then 0x, you don't have to write that. And then 5 times x to the 0 is just 5. The main thing is that don't think that this is how many x's you have, and then this is x squareds and x cubes. You'll be off one. It doesn't go like that. The one at the end is x to the 0s, or those are just called constants. There we go. I have got my answer, and what happened was I got a list of things that could work. Then I just started trying them, and until I found one that worked. How did I know it worked? Because once I tried 2 and it didn't work. Then I tried -2 and it worked because it has a 0 at the end. And so, yay, I was able to factor this thing even not being given the thing in front. All right, so let's say I have a new problem like, for instance, this one. What was the teacher doing right here? What do you think they were doing right there? Not the coefficients, but the constants. This is the factors of the constant. Good. Okay, what do you think they were doing here? Yep, F co. And it's F con over F co. So they took these and divided by 1. Now they put a plus and minus on everything. It's true, but I like to just wait till the end and do that. So then it was 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. And then it was plus and minus of all of that. So what I would just do is this. 1, 2, and 4. And then it's plus and minus of all of that. I know that's sloppy, but you could just put a plus and minus in front of everything if you'd rather. I think it just saves some time to put plus and minus out front. All right, how do you know which one actually works? What the point is this thing needs to get factored, and I need to know which of those works. So you try synthetic. And you try it on a whole bunch of them. All right, so here's one where, actually first, I'd like to do this one with you. I want you two to just figure out what are the possibles on this one. There's a whole bunch. Can you do F con and F co? Divide them. Make me a list, and I want to know. I think there's 8 of them when you include positive and negative. Try that. This is, again, a replacement lesson for the people that missed class yesterday about factors of the constant, factors of the coefficient. You should have already found the factors of the constant. What did you guys get for the factors of this constant? 1, 2, 3, 4, 6, and 12. Good. Holy cow, there's a lot of them. And then we divide that by the factors of the coefficient. The good news on this one, if there is any, is that the coefficient, the lead coefficient, is just 1. Okay, so then when I divide all of those by 1, they're just the same thing as they were. So I put 1, 2, 3, 4, 6, and 12. And it's plus and minus of all of those. All right, cool. That's how you find the possibles. Did you catch what I just did there? All right, good. Now, if I want to use this information, one of these would work if I did synthetic on it. But I don't know which one. And it is a pain. And we aren't giving you any like cheat ways to do it. You just have to grunt through it and try them. So on this page, we've got them all written out so that this has already got its list of possible roots. And you just got to test them all and see whether they work. All right, I'm going to give you a hint that one doesn't work. I'm going to cross all those off. I'd like you to try the ones on this page and find one that works, and I'll try to show you what to do. It's just grunt work. Just do the synthetic on these. We'll start by dropping the first one. I'll pause for a second while you try that. All right, so kids found that 4 works. They tried 1 here. 1 times 4 is 4. That's add them down 0, multiply them 0, add them 1, multiply them 4, and I get a 0 at the end. That's how I know it worked. That was the remainder. Now, what does it mean What it means is factors. Did you guys already write this out? Did you get x minus 4 for this one? And then the factor that goes with this would be, this is the x to the zeros, x to the ones, x to the twos, x squared plus 1. Make sense? All right, you've learned it. That's all you got to do. Now, the only complications from here are that, don't forget you're not done until you have finished and got the roots. So the root of this is x equals 4. The root of that, you got to go x squared plus 1 equals 0, x squared equals negative 1, square root, absolute value of x is I, and then split it into two things, x equals I, and x equals negative I, and I got that, and that, and that. Yes, that's the same thing as x equals I and x equals negative I. I like to write them separate. Here's why. When kids see this, they often say that that's one answer, and then that's the other answer, and they're like, well, I'm supposed to have 3 answers because of the problem, but that's actually 2 answers. So if you split them up, you'll know for sure it's 2. I'm fine with either one. All right, so that is a quick lesson. If you had to do one from the start, this would be an example of one that you'd just say, okay, I don't know what goes into it, but I could do my rational root and figure out what the possibles are, and then I could test a bunch of things. All right, so do you want one summary problem? You guys that are sitting in front of me, or do you want to be done? I'm okay with either one. You good? One summary? All right, so then you guys can either watch this or you can work on your homework, whichever you'd like. All right, so here's the summary problem. I need the factors of the constant, right? What are the factors of 6? 1, 2, 3, and 6. Good. What are the factors of the coefficient in the front? Just 1. And then if I'm just dividing by 1, then my answer to this is 1 and 2 and 3 and 6, with a plus and minus in the front so that I remember they're all positive or negative. Then let's save a whole bunch of grunt work. You try one, it doesn't work. I'll show you one where I'm trying it and it's not working. Stick a 1 in. And this is 1, negative 1, negative 5, negative 1, negative 6. Draw the line, drop it, 1, 1, 0, 0, negative 5, negative 5, negative 6, negative 6, and it didn't work because it didn't equal 0 at the end. It equaled negative 12. See how I checked? Now it didn't work? So now I'm going to check a different one. At least all these numbers are the same. And I'm pretty sure I remember that 3 worked. We'll find out. So I dropped this. Would you please check that one yourself? See if it works. Okay, so my student checked and it did work. I will show how it works. This ends up being a 2, and then that's a 6, and that's a 1, and then this is multiplying, and then this is adding, and this is multiplying, and this is adding, and it's a 0. Sweet. So then this is x minus 3. This is a 2. This is a 1x. This is a 2x squareds. And this is a 1x to the third. And there's pluses between everything, and there you go. But you can't just stop right there because this has to be factored further. Now, hint, option A, you can take the same list of factors, and now there's less of them. Because do you get, we had a 3 and a 6 in our list, but now the factors of the constant here is only the 2 and the 1. So now 1 or a 2 must go into this thing. And you could do it with synthetic. Or, personally, I'd just factor by grouping. Do you remember the factor by grouping thing? And then I take x squared out of this one. And here's the weird part. How do you factor that? You just take a 1 out. And then I have x plus 2 left. Then this one was x plus 2. And then, final answer, x minus 3 comes down. This part, the x plus 2's are in common, so they come next. And then what's left at the end is x squared plus 1. And there you go.
What do you do if there's the other factors for the coefficient if it's not 1?
Okay, then let's say on this next problem, the question is, what if this has factors that are more than just 1? So we do fcon over fco, and there's just a lot more in your list. The factors of the constant are 1, that's the constant, and 2, and 3, and 6, right? But then this also has a 6 in it, so the factors of that are 1, and 2, and 3, and 6. Now, this is brutal, but you'd have to take all of these and divide them by 1. So 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. And then I think you get the idea, it's going to be 6. And then you're going to have to take all these and divide them by 2. What's 1 divided by 2? It's 1/2. And 1 divided by 3 is 1/3. And 1 divided by 6 is 1/6. And yes, those can be factors, even though they're fractions. And then I'd go through and take all of them and divide them by 3. So 1/3, 2/3, 3/3 is equal to 1, 6/3 is equal to 2, and I already have those on my list, so I don't need to repeat them, but get the idea. And then you get this huge, nasty list. You check every single one of them with synthetic. Now, there are better ways to do this. There's, like in the real world, if you were going to factor this, you would probably resort to using a calculator and having the calculator tell you where the roots are. Because if you graph it, remember how if it goes like this and it touches here, it's telling you a root. So that's a way to find the roots a lot faster. But we're only going to do like one of these really big, nasty ones to you. And you're just going to do a lot of practice on synthetic until you find the one that works. Okay, so there's my summary lesson to replace the one where the sound didn't work. And that's all I got for you for today.